111 Eagle Street, one of the most prestigious new developments in Brisbane, destined to become a pearl in the crown of the fabulous buildings in this upmarket section of the Brisbane River. And the piling and diaphragm wall was completed by Avo Piling.
The job entailed creating 3 tower columns, 8 plunge pile columns and the diaphragm wall, which was part of the retaining structure. The biggest challenges were the actual job site. The area itself was very small, and having to use such large equipment in such a small confined area was one of the major challenges.
Avo Piling. Quality, dedication, commitment to excellence. And all this starts with thorough planning.
Prior to actually setting up on site, we spent 4 to 6 months planning. We used Inventor. I think it was Inventor number 9 to do a lot of the work, and to draw up the desanding unit, which was one of the major items of plant that was used on the project, and the fact that it had to be set up on a extensive grillage steel setup, which was then set up on top of 2 basement levels, which was also propped from below. This took a lot of thought and effort and time to get it all organised.
The project took 8 months, with the cutter the centrepiece of the operation. Pre-excavation. The mechanical grab removes soil, preparing for the cutter. The cutter is placed in position and used to excavate the extremely high-strength rock. Next, stop-end removal. The stop end was in place to create a shear key and provide a joint between panels. Here, the full length of the stop end is seen. The cutter moves forward. Let's examine how this modern marvel was able to cut down 6 stories and create a perfectly vertical wall, sight unseen, from the Earth's surface. David Tavanian personally supervises this aspect. It is this personal attention to detail, this unique management style, that sets Avo Piling apart and guarantees quality. As the cutter digs deep, let's examine the business end of this remarkable machine.
The cutter that we're using, the BC32, which is built by Bauer, it does have the flap tooth system, where the tooth, as it comes around and starts to cut the material, it actually flips into the centre and cuts the centre out to make sure that the cutter can progress through the rock. The role of the bentonite is certainly to keep the excavation open. It creates a hydrostatic pressure, and it allows the hole to be kept at its correct width, so as we can carry on the excavation as we continue on through the rock. Certainly in sands and clays it does an excellent job, and in rock it's not needed as much, but certainly if you have sand layers or something along those lines, it will stop any material from actually entering the excavation.
These silos carry fresh and working bentonite. Used bentonite from the excavation is pumped to the desanding units. This is the extremely high-strength rock being excavated 24 metres below ground. From here, the rock will be trucked away. Up to 15 metres of rock was excavated in the panels on this particular project. The advanced touchscreen interface offers precise control over every aspect of the cutter's operation. These flaps are the key to maintaining a perfectly vertical cut at deep levels.
Certainly the ability to steer the cutter with the flaps is one of the major keys to the cutter doing its job in the correct fashion as well. The verticality of a diaphragm wall is always a key ingredient in the quality, and obviously the client is always asking, are you going to meet the specification on the verticality? And to have the ability to actually steer the cutter in real time at that point where you can see it starting to deviate is a major ingredient in the cutter doing its job.
Worn teeth are replaced with new ones whenever necessary.
In our process that we use a working bentonite, which we use during the cutting phase, and then once we have completed our cutting phase, then we are going to start concreting the panel to set up for the cage and the stop end. We then remove the working bentonite with the concreting bentonite.
This rubber water stop will protrude from the concrete, creating a waterproof seal between panels. The reinforced steel cage is lifted. By viewing its length, the depth of the hole can be imagined. Spacers are fixed to the cage for correct cover for the concrete pour. The cage is placed at the correct height. Finally, the tremie funnel is put in place for the concrete pour.
Yeah, it's been really difficult, but you know, it's all about coordinating with what's going on down there. It's been a really difficult job because of all the old foundations that were in the ground. So, you know, it hasn't been an easy job by any means, but I think we've pulled it off really, really well.
Certainly the mechanical grab did a brilliant job for us. The 3 cranes were excellent on site. The cutter itself, along with the desanding unit up the top there, all performed excellently. We really didn't have any major issues with any of the machinery on site. The project manager was happy that we managed to finish the project in the time that we were allocated, and certainly to finish it without any major incidents was in such again in such close proximity to the people around and public around. It was very much appreciated.
It's been a good job. The morale and everything of all the workers is pretty high. Trying to finish the project on time. It's good. It's you're just not a number. You're part of the company. It's a good family company.
Founded in 1989 by civil engineer Avo Tavanian, and operating from spacious warehouses in Unanderra, New South Wales, and Clontarf, Queensland, Avo Piling has a proud reputation and a management style which motivates workers to peak performance.
On my behalf, I was very proud of the way the guys worked on site, and really appreciated the way that they worked during the project.
World-class management, world-class results. 111 Eagle Street, Brisbane. Another proud ground engineering job by Avo Piling. Avo Piling, a legendary name in Australian civil engineering.